What is necessary for the survival of our civilization? At its simplest, we might say people and the resources that sustain life. Yet more crucial than either alone is the balance between them. Throughout history, many civilizations have risen and fallen, often collapsing at the height of their progress and technological achievement. Today, we have gone a step further by creating a new kind of competitor in artificial intelligence. It accelerates our pace and amplifies our capabilities, but also intensifies the pressures we face. The path to this point has been long, from the discovery of natural laws to the harnessing of electricity and development of advanced materials. But this progress has come at a cost, shaped largely by systems driven by capital and profit. We now find ourselves in a troubling paradox where we can no longer grow food without first protecting it often by poisoning it with pesticides. We have already contaminated the air, water, and soil that once sustained agriculture naturally. In doing so, we harm not only plants, but also animals, including bees, our most vital pollinators. Meanwhile, oceans, seas, and even our own bodies are increasingly saturated with microplastics and other pollutants. Freshwater resources are diminishing as rivers and lakes dry up. Human fertility is declining, as is the fertility of the soil that feeds us. And alongside these environmental and biological strains, artificial intelligence looms ever larger, challenging our place and our future. War, of course, is not new. It has been a constant throughout human history. But taken together, these converging crises raise an urgent question. What is the true state of our civilization in 2026? Bees are often described as the most important animals on Earth, not because of their size or intelligence, but because of their invisible labor. They are the foundation of terrestrial ecosystems and modern agriculture. Roughly 3/4 of global food crops depend at least partly on pollination, much of it carried out by bees. This makes them not just insects, but a biological infrastructure sustaining human civilization. 100 years ago, bees were abundant and diverse across almost all ecosystems. Long-term datasets and museum records show bee diversity and abundance stayed relatively stable until the late 20th century. After the 1990s, bee populations began to decline sharply. Global data shows about 25% fewer bee species recorded between 2006 and 2015 compared to before 1990. In North America, nearly 35% of native bee species are now at risk of extinction. Bumblebee populations have dropped dramatically, with declines of about 46% in North America and contractions in Europe. Some individual species have collapsed, almost completely losing 90 to 95% of their historic range. This does not mean bees are almost gone in absolute numbers, since humans actively replace honeybee colonies. But natural self-sustaining populations are collapsing, and biodiversity is shrinking. One primary cause is industrial agriculture, which relies heavily on pesticides and herbicides. These chemicals can poison bees, directly weaken their immune systems, and interfere with navigation and reproduction. Habitat destruction from urbanization and large-scale monoculture removes wildflowers and nesting areas bees depend on. Climate change alters flowering seasons and shifts ecosystems, making food availability unpredictable for bees. Parasites and diseases have spread through global trade, devastating already weakened populations. The loss of wild bee species reduces ecosystem resilience and cannot be compensated for by honeybees alone. Pollinators are essential for crops that make up a healthy human diet, including fruits, vegetables, nuts, and oilseeds. Economically, pollination supports global agriculture, and its loss would destabilize food markets. Ecologically, bees maintain entire food chains, and their disappearance could trigger widespread ecosystem collapse. Humanity is not facing immediate extinction due to declining bee populations. However, the long-term danger is profound, with gradual breakdown of food systems and increasing inequality. Declining global health and environmental instability point toward a slow degradation of civilization rather than a sudden catastrophe. The modern way of life reflects on the global state of male and female fertility. One of the most widely cited findings in reproductive epidemiology is the long-term decline in sperm counts. Large meta-analyses report that global sperm concentration and total sperm count declined by more than 50% between 1973 and 2018. The rate of decline appears to have accelerated after 2000. Male infertility affects roughly 7% of men worldwide. Parallel to this, infertility more broadly is widespread. About 1 in 6 people globally experience infertility during their lifetime. These numbers justify concern. Even if sperm count is not the sole determinant of fertility, it is a key biomarker of male reproductive health and general physiological condition. In women, infertility is influenced by a range of biological conditions, including hormonal disorders, tubal damage, and age-related decline in ovarian reserve. Yet perhaps the most significant factor shaping fertility patterns today is not biological but social, the widespread delay of childbearing. In many parts of the world, women are having children later in life due to education, career development, and economic pressures. This postponement intersects with the biological limits of reproduction, contributing to lower birth rates and increased demand for medical assistance. The causes behind these reproductive trends are multifaceted and not fully understood. A prominent line of research focuses on environmental exposures, particularly endocrine-disrupting chemicals found in plastics, pesticides, and industrial pollutants. These substances can interfere with hormonal systems and may have especially profound effects during fetal development, potentially impairing reproductive function later in life. In addition, lifestyle factors such as obesity, smoking alcohol consumption, poor diet, and chronic stress are known to negatively affect both sperm quality and female reproductive health. Water is often described as the most abundant resource on Earth, yet this perception is deeply misleading. While oceans dominate the planet's surface, only a tiny fraction, less than 1%, is accessible fresh water suitable for human use. This limited reserve is now under increasing pressure from population growth, climate change, and unsustainable consumption. As a result, water scarcity has become one of the defining global challenges of the 21st century. Billions of people already experience water shortages for at least part of the year. Global demand for water continues to rise steadily. Agriculture alone accounts for roughly 70% of freshwater use. Many farms rely on inefficient irrigation systems that waste significant quantities of water. At the same time, pollution further reduces usable supplies. A large proportion of wastewater is discharged untreated into rivers and lakes. These pressures are compounded by climate change, disrupting rainfall patterns and intensifying droughts. Climate change is also accelerating the loss of glaciers, which act as critical natural reservoirs. The consequences of this crisis are visible in the dramatic decline of major lakes and inland seas. The Aral Sea has lost over 90% of its volume due to river diversions for irrigation. Lake Chad has shrunk drastically, affecting millions who depend on it for water and livelihoods. Lake Urmia and the Dead Sea are other examples of dramatic regional water loss. Both human mismanagement and environmental change are driving this global pattern of water loss. Looking ahead, the future of global water resources appears increasingly uncertain. Projections suggest that within a few decades, demand for fresh water could exceed supply by a significant margin. This imbalance threatens access to drinking water, food production, economic stability, and public health. Regions already vulnerable to drought and poverty are likely to be hardest hit, risking migration and social unrest. Soil infertility and declining crop resilience are central challenges in modern agriculture. Agriculture has shifted from biologically rich systems to controlled, input-dependent ones. This transition helps explain why pesticides, herbicides, and other treatments have become so widespread. Soil infertility is not simply the absence of nutrients, but the degradation of a living system. Healthy soil contains a vast network of microorganisms, fungi, and organic matter that support plant growth. Decades of intensive farming have disrupted these systems through monocultures, heavy tilling, and synthetic fertilizers. Chemical fertilizers can replace nutrients but cannot restore the biological complexity of soil. As a result, crops become more vulnerable to disease, pests, and environmental stress. Even greenhouses and glasshouses cannot fully escape these problems. Pests and pathogens can enter through air, water, soil, or human activity. Controlled conditions can sometimes accelerate the spread of disease by creating ideal environments for fungi and insects. The broader implications for global food production are significant and worrying. As soil degradation continues and climate change intensifies, maintaining stable yields becomes harder. This threatens not only the quantity of food but also its nutritional quality. Soil infertility is part of a broader transformation in agriculture under rising global food demand. The challenge is to balance productivity with sustainability to avoid further undermining natural systems. The rapid advancement of artificial intelligence has led many to question whether machines may one day surpass human capabilities. While humans have long been the dominant force on Earth due to intelligence, creativity, and adaptability, AI is beginning to challenge that position in significant ways. Artificial intelligence already exceeds human performance in specific domains. It can process vast amounts of data in seconds, recognize patterns invisible to the human eye, and operate continuously without fatigue. In fields such as medicine, finance, and engineering, AI systems are capable of making faster and often more accurate decisions than human experts. Unlike humans, AI is not limited by emotion, bias, or physical constraints, which allows it to function with a level of efficiency and consistency that is difficult to match. A more nuanced perspective highlights this transformation. Approximately 44 million jobs are considered at risk due to automation and AI, yet around 68 million are not disappearing, but rather changing in nature. This distinction is crucial. Many occupations are being reshaped, requiring new skills and workflows, rather than being entirely replaced. The impact of AI, therefore, lies less in elimination and more in redefinition. Looking ahead, the future of work remains uncertain, with predictions varying widely. Some estimates suggest that up to 47% of jobs could be at risk, emphasizing the disruptive potential of AI. Others, however, forecast net job growth, driven by the creation of entirely new industries and roles. The most realistic outlook likely lies between these extremes, acknowledging both the risks and the opportunities. Ultimately, the rise of artificial intelligence presents both a challenge and an opportunity. Rather than signaling the end of human work, it marks the beginning of a profound transformation. The key question is not whether jobs will disappear, but how societies will manage the transition, ensuring that workers are equipped to adapt and that the benefits of AI are distributed broadly. While we watch the nearby river flowing and listen to the buzzing of bees in the nearby meadow, that statistically small space for these great questions of civilization, it seems that the voice of life does not change, but the same question remains: how much time do we have left?